Hi everyone, I'm Julia Hyder, Senior Editor with Morden Machine Shop, and I'm your moderator for today's webinar, which is sponsored by Hurco ProCobots. In today's rapidly evolving manufacturing landscape, job shops face challenges stemming from a severe labor shortage and the growing demand for faster job setup times. This presentation will delve into the crucial importance of automation for job shops and highlights ProCobots' high-mix, low-volume automation solutions. We'll also take you through the step-by-step process of automating a part for Hurco CNC mill using ProCobots automation software. Our presenter is Stephen Gerhardt, ProCobots automation application engineer. Stephen is an experienced automation application engineer with a strong background in manufacturing, specializing in CNC machines and automation technologies. With 15 years of industry experience, including 6 years at Hurco ProCobots, Stephen has played a significant role in driving efficiency and innovation in the field. You can submit questions at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. There are also some polls throughout the presentation and a handout that will be available at the end, so keep an eye out for those. And finally, I wanted to let everyone know that this webinar is being recorded and attendees will receive a link to the recording via email. So with all of that out of the way, let's get the presentation started.
Hey there. Yeah, so like she said, I'm Stephen Gerhardt, so 15 years of manufacturing experience. I started out just after high school in a machine shop, actually doing assembly stuff first and manual machining, CNC. So kind of worked my way up as I was going through college, started at Hurco, doing some software testing, and got introduced to, kind of like, Two Worlds meeting. I really wanted to get into automation, and the initiative for automation at Hurco was really starting to take off. So yeah, got to be with ProCobots right at the beginning there. So 5 years with ProCobots, we began integrating on all types of CNCs. But after a while, we kind of just focused on Hurcos after acknowledging our strengths and what we're good at Hurco. And so we, developed a solution through all of my years in manufacturing. I saw customers' frustrations and needs, and helped to develop a solution, taking inspiration from the Hurco control to implement an easy solution to pretty much automate all kinds of workflow, taking advantage of what we'll talk about with Cobots and the software that's out there currently. So ProCobots, like I said, it's about 5 years old. It was established as Hurco's automation group in 2019. We offer a complete package containing all the hardware and software required for unattended, lights out machining. And we focus on high mix, and I say low volume, but really it's all volume. We've done high production, low production, but the main focus is that high mix, small batch orders, things like that, job shop work. So our mission is then to provide a sophisticated yet simple control while empowering the owner. So what I mean is, the customer owns the system as far as making fingers and what you'll see, grid trays and things like that. We encourage, the shop owner to take ownership of the system and make the most of it. So yeah, why automation? Why now? So there is a major labor shortage out there. If I'm sure a lot of you are aware, it's really hard to find good quality workers, especially, in the industry, small machine shops, especially out in the middle of nowhere. It's hard to find good workers. So we have the major labor shortage, and then right now the technology is ripe for small scale automation. And what I mean for that is really the hardware is there, the software, it's all coming together at a head in order for us to really automate parts that we weren't able to easily or efficiently automate, 10 years ago, for instance. And that leads to job shops are no longer excluded from automation. So this is all obtainable now. It's no longer the manufacturing, the large scale manufacturing, automotive, things like that. The pole barns that are job shops can now have robots tending machines. So the first thing I'm going to focus on is the labor shortage. So this slide just shows, the worker pool, the population being from 16 to 64. And this really just shows how in the last, 70 years or so, there's been a labor, 45 years or so, there's been a labor surplus. So, fast forward to today and in the future, we're really starting to see a decline in that availability of workforce. And there's no end in sight for that, to be honest. So, like I said, first time in 45 years, there's been a global labor shortage. Now, that's a national or world. This is worldwide picture. So 43 million workers worldwide, a shortage. But high income countries like the United States are actually much worse off. If you look at this graph, we kind of bottom out here at 0.4%. That's globally. The United States is more at like 4.9. And the exceptions here are Africa and India. Those are the ones that kind of, kind of level out this graph where it should be a lot more extreme in places like the United States. So the takeaway is that now automation is driven, by the labor shortage and not necessarily just trying to be more productive or cost containment. So, this graph shows that there is expected to be a 7.5% population growth between now and 2030. So the ideal supporting, workforce pool for that is, 15 million, and 63% of that is what we consider like the ideal, like, participation. So, not everybody available to work is going to work. So that's the ideal situation. Here's reality. The projected, pool of that 16 to 65 or 64 is only, growth of 1.2%. That's just the pool. And then 63% of that to be, projected to participate is only 1.6 million. So there's a shortage of 8.3 million people to support the population growth. So that's where robots come into play, right? So what is a cobot? A cobot is a type of industrial robot that is really designed to work around humans, assist with tasks, being easy to program, they're flexible, and safe. So unlike traditional, industrial robots, cobots are intended to do that human to robot interaction, making them ideal for small businesses with varied needs. Excuse me. So there's a video of me getting bumped by one of these robots. So they're designed with safety first. Each joint has these voice monitoring technologies. They're low energy compared to like traditional industrial robots. And they're, of course, in compliance with ISO standards and things like that. And we do a risk assessment on every installation based on the application. So, depending on the part that you're holding, things like that, we have to take in consideration. Obviously, if the cobot's wielding around knives, we kind of have to think things a little differently. But generally, these things do not require area scanners, fences, and that, helps keep their footprint really small. So just a quick little comparison between cobots and industrial robots. So, I want to say that they're both kind of like industrial because they both have, a place in industrial environments. I think a better way to really compare these two is that one is for high mix, being the cobot, and one is for low mix, being like industrial. So for flexibility, the cobot's really easy to use, whereas the industrial robot is like highly specialized. It's meant for a task. It's designed for a task and purpose in mind. Same thing over and over, a million times in a year, that kind of thing. And like I said before, we're safe and approachable with the cobot. Industrial robots, not so much. You have to be a lot more cautious and guarded and things like that. And the upside to that is that, industrial robots are extremely fast. There's higher payload. But with what we're doing with machine shop, machine tending, we're able to get away with that because most of the time the robot is sitting there while the machine is doing the work. So, we also have like a lower initial investment with cobots as well. I mean, there are quick setup times. That's really what we focus on. Whereas industrial is like long-term cost efficiency. You set it up and you don't touch it for, months or years as it's doing the same thing over and over. So you can calculate ROI with the cobot, and it's a good thing to do, but it pays for itself within the first year, especially our systems. That's what we've really seen. So, and with the application, they're easy to use. And, like I said, it's just really high mix versus low volume. So this next slide here just shows cobots are in the market with industrial robots. So cobots really started to come into picture in the 2010s. And then, as you see in the last 5 years or so, the red shows their market share, and they're really starting to become, an important part of the market, of course. So, you're looking at now 1 in every 10 robots is collaborative, so 10% of the market share. And year over year, that's been a 31% increase in the last 5 years. So back to these questions. Second point, the technology is ripe for small scale automation. So poll time. I'd like you guys to fill this out. If you could tell me, what do you find relevant, in your current manufacturing needs? Or how do you find automation to be relevant in your current manufacturing needs? So if you can chime in, is this coming in the background or?
No, it just is a poll that people could, I think you can pull up the answers, but.
Yeah, okay. That's all. Just wanted to be sure. So I'll give you guys some time to fill that out. So depending on your answers here, you may be asking yourself some of these questions. So I hear it a lot, some common reasons why people choose to just struggle over adapting automation. So some people say, I don't do enough of the same parts to use a robot. And that's probably the biggest one. Excuse me. Traditionally, that would be true, right? With industrial automation, it takes a long time to set up, lots of money, lots of specialized programming, things like that. Well, what we focus on is really quick changeover. As you'll see throughout my coming slides, it's really easy to set up these robots now, and to the point to where we've made it to where in less than 5 minutes, you can set up a part you've never automated before and have the robot to the machine. So when you do that, you now have these small 1 to 2 hour batch sizes that are now obtainable for automation. It takes so quick and easy to set up. It's so easy to set up that now those couple hour run times are, it's worth it. It's worth the effort. People say there isn't place in their shop for a robot cell. Yeah, traditional robots are huge, or they can be. They can take up a lot of space with the area scanners being, 3 meters of dead space around it. Safety guarding, things like that. With the Cobot, because it doesn't need all of that, and our compact, as you'll see, our table, we're at about a meter square of space. So really, if you have room for an operator, you have room for one of these robots and the parts. Can't afford to dedicate a machine to automation. I understand that completely too. And that's what we've done with our system. And I think most systems should have this, casters on the thing, so you can move it from one machine to another. But a big part of that for us too is that we have a quick connect to connect the robot to the machine, as I'll show you. And that's really important because we want to be able to make the system flexible. Maybe this machine is on a 5-axis machine and you have this big part that isn't really robot friendly. You want to run manually. Instead of the robot just sitting there, you can roll it to a different CNC machine or out of the way, things like that to make it flexible. We really focus on that. I don't know anything about setting up a robot. That's fine. We do. And that's what we do. So we set up the robot, we program it. And then our interface is all you have to interact with. It's conversational, parameter based. So you don't have to learn about how to program the robot. And yeah, it sounds too good to be true. Well, yeah, it's true. So first we got to think about a robot. When we do automation, of course, the first thing is, of course, the robot. So we use universal robots for lots of reasons. They have a range of payload capacities now from 12.5 kilograms all the way up to 30. So we can lift a range of parts, large parts. They're the pioneers in collaborative robots. They have a wonderful, programming environment, which allowed us to make, really powerful and flexible software. The force torque sensor at the end of the UR emulates the human touch, and there's no other robot out there quite like that. And we can use this remote free drive that allows us to grab the robot and show it where to place the part. And I have some examples of that here to show you soon. And it's easily powered, just by a wall outlet, lightweight, compact. So they've been a great partner for us. Next, where are we going to put the robot? So we have these tables that we put the robot on. It allows us to present the parts in a nice, orderly fashion. So 2 models that we really focus on for our machine tinting application. We have the flat tray, which allows us to stack parts. Compact design, like I said, about 1 meter square. And it utilizes that robot reach so we get the most out of our work envelope. And then we have our drawer system for taller parts or maybe parts that, you want to get high capacity, but you can't stack them. So we can configure these between 5 and 10 drawers. They're dual-sided openings. So what that means is the robot can have 1 drawer open, tending to the machine, and the other 9 are available for the operator to open and load and unload and things like that. So depending on the configuration, we can do parts that are 80 to 160 millimeters tall. And of course, both of these, are robust and rigid. So then we got to focus on part presentation. So, there's a lot of buzz about vision systems, and they've come a long way in the last couple of years, but it's kind of overkill for what we're doing. It's expensive, it's overly complicated, and as far as picking up a pool of parts, different size parts, you can have issues with reliability when it comes to machine tinting parts and things like that. So we don't go with vision. Angled pegboards, those are a great solution as well. But I think they're tedious to change the grid size if you want to do different size parts, and you're limited to short parts, short stacks because of the angle. So we focus just on a flat grid, so we can quickly swap out those grids to have different size pockets for different size parts. It's simple, just straightforward. And we can actually stack parts with these, a large stack. We can do a large range of part sizes, heights, things like that. So then we have to think about work holding, right? Inside the machine, got to automate the work holding. So there's a couple options to do that. We focus on, these 3 mostly. Rapid Design has a nice add-on to a Kurt vise and orange vise, different types of vises that take an existing, manual work holding that most of you guys have in your shop and turn it into an automated vise, which is, very innovative solution there. So it has a high clamp force. We love using those. Then we have, air vise and shunt for like the smaller, compact, soft jaws, hard jaws, work holding there. And then we also, we have our pneumatics panel on the Pro Feeder for ease of access to do the, to adjust the regulators, pressures, and things like that. So then dual gripper options. We focus on the adaptive gripper from Robotique, and then also pneumatic. We use Shunk for that, and they both have their place. So the adaptive gripper is really about, if you can use it, it's great to use it because you have that programmable stroke, allows you to pick up a range of parts. So what I mean by that is you can have a range of parts. Let's say I have a 1-inch part and a 3-inch part. Thanks to our software, you can queue and load those jobs to run back-to-back lights out. So it'll run, let's say 50 of part 1 and then 50 of part 2. So, with the adaptive gripper, you're able to pick up and adjust the fingers to different size parts. Whereas pneumatic, you're more, it's either open or closed. You can have some positions programmed, but it's still kind of predetermined. You can't really just variably do it on the fly without having some sort of manual interaction. So why dual gripper? We use dual gripper because it allows us to make the most of our time. The robot can pick up a part with gripper 1 while the machine is finishing the cutting, so do what we call staging, and that time savings can actually add up to hours in a workday. And gripper 2 is still free to grab that finished piece out of the machine, and then we do what we call an exchange and then place part 1. And this is much easier to do with an automatic door. So that gets me to our next slide. Automatic door. So there are there's a couple ways you can do the door opening. I've seen people use, robots to open the door. While that's a way to do it. Robots like consistency, and you get a lot of variation with the opening of the door. And also if it's a dual door, that's not efficient either. And you can't open the door while the robot's in movement, right? So we save some time by doing that. And then you have pneumatic, which Pneumatic isn't collaborative, and it doesn't allow the operator to manually open and close the door very easily. So we went with, a collaborative servo-driven door. So it can, act like an elevator door if it comes across, something in the way, it doesn't hurt you. And we actually have our switch too, so you can easily open and close the door. And that's nice, such a nice, convenient, it's a nice quality of life improvement for operators that even in systems that we don't automate necessarily, we still sell these auto doors just because they're so nice to have. So like I said before, flexible automation. We got to be sure that we can move this thing to a different machine or out of the way based on the dynamic needs of the shop. That's the thing about a job shop. You have multiple size parts coming in. It's never consistent. You never really know the workflow. So it's nice to have something adaptive that you can move from one machine to another. So we achieve that by having the casters on the Pro feeder on the table to move it around. But also we have this box on the back of the machine. And we assemble this at Hurco. Of course, we install it on new machines if they have automation. But if it's a retrofit, it's just magnets. So we just slap it on the back of the machine. We land like 6 wires, and those are just to tie the e-stops together. But yeah, that black box houses all the connections for the auto door to the robot, and that's all done between the machine and robot with the Ethernet control or Ethernet signal, sorry. And we have this e-stop jumper that jumps the e-stop to seal that off if we do move the robot from one machine to another, so the machine can just function as a manual machine. So obviously, reliability and consistency is really important when it comes to automation. Without that, you can't ever trust the system to run while you're not around. So we have this air blow, this air nozzle that will blow off the vise before it places a part in there, and also blows off the part as it retrieves it. And as you'll see here in a minute, we also have a part flipper. It'll blow off that too, so we're not getting chips all over our parts and the work holding as we're doing things. And also, we recommend tool probing just for, tool breakage, wear, stuff like that. We've had customers do macros where every X amount of parts, it will, check your tools just to make sure everything's okay. Of course, the robot with that force torque sensor, as it goes to remove parts, it'll know if the machine threw a part. It'll, if it was expecting a large chunk of material to be, removed and it wasn't, it's going to detect that. So that's also a benefit of the force torque sensor, is that we can feel for things inside the machine and kind of detect things if they go wrong. And you can also monitor this stuff. So Hurco has the extended shop floor package, which, that allows you to also monitor your automation. So you can see, a webcam view. We have the job manager screen there. So you can see that dual screen, that second screen where the automation software is running. And on that screen, you can see what the status of the robot is, if it's running, how many parts you've ran, how many parts there is left to run. And then, of course, you get this nice, uptime, percentage, and show you, how the machine's been, how efficient the machine has been throughout the day. And we're also adding features to this ESF2 extended shop floor to support automation and to give you more data. And then we have multi-op processing. So this just takes, op 1, puts in a part flipper, flips it, and then puts it into either a second vise or a stepped vise or something like that to, do that other side. So it really just enables more lights out machining, where you don't have to do all of op 1, somebody manually flip it, then do all of op 2. And so that part flipper, that is a pneumatic part flipper with a shunt gripper on it. They have these quick toolless fingers. You just pull those pins out and adjust the fingers on that like kind of rack base there. There's like a ruler notches that you can, adjust the fingers to depending on the size of the part. So, yeah, another pull, if you will. Which feature of automation do you find most appealing? The ease of setup, no programming required, integration with Hurcos, increased productivity, safety features. I'm curious, what are you guys wanting to see most out of automation? So I'll give you a couple seconds to fill that out, please. All right, move on. So the ProCobots package, this is what we offer to address all of the things that we talked about when it comes to automating a machine. So we have our robot. Like I said, we go with universal robots. We have our dual gripper setup, whether it be pneumatic or servo. I'm sorry, adaptive, not necessarily servo, but adaptive. Our table and part grid for the part presentation and a nice rigid body for the robot. We have our air nozzle for the part cleaning. Our collaborative automatic door. And then our special sauce, personally, it's the automation software that ties everything together. And then our work holding inside the machine and the retractable wheels to move that around, which I don't think I really talked about that. So they are retractable, meaning there's this little ratchet system. Kind of go back in my slides a little bit here. So that ratchet thing there kind of moves the pad for the robot system to sit on up and down. So you just ratchet that pad up, then the casters are on the ground. You can roll the system around very easily. It's nice and fluid. And then once you get in position, you just kind of ratchet that into place. And we don't have anything to like lock the system to. There's nothing like a bracket or nothing like that. And the reason why is what you'll see here in a little bit. It's so easy to reprogram how to load the part in and out of the machine that those things just overly complicate it. So yeah, let's jump back forward here. So yep, our retractable wheels to move it back and forth between machines. So yeah, so why automation again? So job shops are no longer excluded from automation. And that's because we have all of these things coming to a head. So that's great. You have this system. You have all this equipment. Now what? So traditionally, there's this complicated teach pendant. It looks scary. And if you misprogram it, it'll Hulk smash into the table and it's a mess. So you hire an integrator to do all the programming and, it takes a lot of time and sounds expensive. So now these new robots, they have this nice, teach pendant that's like a tablet. The code is kind of friendly, drag and drop puzzles, and it's really easy to use, but it's still programming. So, you still have to do the if statements and the logic, flow of logic, variables, and all of that. And you still have to learn how to do all that and set it up for each job. So it's time consuming. So we take that to the next step and we have this nice job manager. So this is our software that, allows you to just enter parameters about a job and automate it. So no programming. I mean that. Like, you don't have to program the robot at all. You don't even have to touch the teach pendant. It's all done on the Hurco. You just give it information and you do it all within less than 5 minutes on a new part, not just loading something you've done before. I mean, brand new part, set it up. I mean it, like, seriously. Like, a lot of people are saying this, but we really mean it. So the job manager is, our software designed to basically just do that interaction, that coordination between the CNC and the robot. And it's, the picture is a bit dramatic, but seriously, it's that easy. You set it and forget it. I had a customer once tell me that, like, they were all just sitting around drinking coffee after we did the installation, just watching the robot run, So yeah, so work order, job management, pretty much just enter all the data points to automate a part. And you just grab the robot, show it where to drop the part off inside of the machine. And then you can queue up multiple parts for lights automation, thanks to, the adaptive gripper, having different stroke, having multiple work holding inside the machine. You can automate different size parts, doing different cutting programs, things like that. Excuse me. So first thing we would do is set up our grid, so we can easily change these grid trays, like I mentioned before. And in the software, in our software, you just enter the rows and columns and the grid size. You can save these, load them, depending on the grid size that you load. So you don't have to keep entering that information in every time. So we have customers changing these out multiple times a day. The purpose is the different size grids allow you to run different size parts. It's a nice reference point to put the part in. So you have that consistent location, because once again, robots love consistency. A nice consistent location for the robot to pick up a part. So like I said, a job in the scope of our job manager is a file that contains all of the data points to automate a part. So that could be the location of the cutting program, whether it be NC or conversational, the location of what we call the exchange program. So that is a specific NC program that runs before every robot load and unload. And what that does is it just moves the table into position. And it's a dedicated program that does that. So you do not have to modify your current cutting program. Traditionally you have to throw a bunch of M codes in there, positions, things like that. Not for us. And then, of course, the XYZ coordinate of the part in the grid for the gripper to grab the part and place it back in there. And then where the parts are located in the grid, how many are stacked, special options that change the robot behavior. So still taking that no programming approach. If you want to pick the part up 90 degrees, or if you want to do an ID grip, if you want to change where the workpiece stop inside the vise is, which direction it is, or if there isn't, not one at all of that is just special options that we can set without having to, reprogram anything in the robot. And then, of course, the location inside the machine to load and unload the parts. So I'm going to walk you through on what it's like to create a new job. You would set your NC or conversational program up here in job program. It automatically populates standard positions for your table. So that exchange position program is already in place. Same with the robot program. That's all standard. And so the next thing would be to enter the part dimensions. And it's as simple as just measuring the X, Y, Z, part height. We have the gripper offset. So how far it is away from the bottom of the part or where you want to grab it. So then once you fill that out, we go to our patent pending process. This is really our special sauce here. Our two-step process to basically guide that robot into the machine, into the work holding, and it'll essentially use that force torque sensor in the UR to essentially probe the center of the vise to have a nice, consistent drop-off point. So this is a video of us doing just that. So colleague Matt here has just press step 1. It's going to go and grab the part based off of the dimensions that I gave it. And once it goes inside the machine, it's going to go into what we call free drive mode. And while the program's running, you can grab the robot and guide it with the part inside of the work holding. And then once you're inside of the work holding, you hit continue there, and it's going to use that sensor to essentially, like I said, probe the center of the vise. So it did a quick probe there just in case you have a dovetail, so it knows not to snag on it as it comes up. And then it does a more accurate probe here, back and forth. And then it stored that location. Now it's going to do a test run. So just as it would inside the machine on a normal run, it's going to load the part, find that workpiece stop. And then we have a special option that we enabled that allows it to come up, close the fingers, and then press down with a force that's also can be defined in the job manager as it clamps. And there are different options for loading the part. You can have it clamp before the robot releases, or the robot releases and then the machine clamps, so the vise clamps down, things like that. Once again, all parameter based. So then step 2, same deal. He's going to hit step 2 and the robot's going to move inside the machine. But ideally before step 1 and step 2, especially if you do not have a workpiece stop, you have to find your part 0, do your part setup, because the robot just put the part inside the machine exactly where it's going to place it every time. So that's where you'd want to find your part 0. And ideally you have a finished piece inside of the work holding so you know where to grab it. So once again, we just guide the robot over the part where you want to grab it. And then right now you'll see the robot jerk there. So it's still in free drive, and he clamped on the machine there. He pressed the button to clamp the fingers. So it grabs the part and kind of centers the robot over the part. So it's consistent there. So you don't have to eyeball it just right. It just, centers over the part. And then, it drops the part off back into the grid based off those dimensions. And you'll see here as it slowly moves down, it's using that force torque sensor to gently place it. So that's all it is. That's all it is to set up a new part. We would then just tell it where those parts are. So you can select them in any order. In this case, I'm just doing a straight across here. You can do a select all, of course, clear all. You can drag and drop to select. And this grid here just represents the table as if you were standing in front of it. You can enable part stacking, dedicate an empty grid to drop off that first stack, and then tell it, where you have parts stacked. You can stack multiple. So if your parts are nice and flat, I mean, you can stack as high as the gripper will allow you to. Have a remainder final stack. If your parts allow for it, you can bin drop off too. So then you get the whole grid available, and you can just drop off into a single location in front of the table, onto a conveyor. I've even had someone drop into a vat of liquid to kind of help clean the parts. And then, in the job manager there, it shows you how many parts you have stacked per grid. And as you queue them up, they'll all be different color coded, and it'll kind of look like a fun game of Minesweeper, if you remember what that was. So then the final step is just to run the job. So hitting that start job actually runs both, the robot and the CNC operation. So the job manager facilitates that communication, the sequence of events. You don't have to do anything else. There's no starting on the teach minute and then starting on the machine. You don't have to make sure the program's in memory on the machine, nothing like that. Hitting start job loads both programs, starts both programs, and facilitates that. And as it's finished, it'll load the next job in the queue if you have one. So just to summarize, the advancement, in this technology is what has allowed us to automate high mix, low volume. And it's not, it's been beneficial, but now it's a growing necessity due to the workforce shortages. And then our package, includes everything you need to automate, from the robot to the software to the quick change peripherals, automatic door, and also training. And, of course, the Hurco support that people have grown to, of course, love. So that's all I have. I'm going to have this video play in the background as we go through some questions, if you all have any. This video is just going to show Matt setting up a part just from start to finish. And leave it open for questions.
All right. Thank you, Stephen. It looks like we're starting to get some questions, but there's still time to submit one. You can do that using the Q&A tab at the top right of your screen, and we'll do our best to get to it. But if we can't get to it today, someone can follow up with you via email. So it seems like the big question is, does the system work with machines that are not Hurco?
Yeah, so our system, we focus just on Hurco. The job manager, especially, that was designed with the Hurco control in mind on a Hurco control. But we do have a close partner that does, automation on non-Hurco machines. And if you reach out, we can give you their contact. They'd be more than happy to help you automate.
Awesome. Next question. This is a little bit unclear. So Dave, if you want to follow up, but he says, so a part that would use a 6x6 grid that will dictate the part size. If you could just go over that section again.
Yeah. So the grid itself, you can have a grid be any size. I mean, you could have the whole thing just be a 1x1 if you wanted to. So the robot can handle, pretty much any part size as long as the gripper, can open up that much, which we have extensions to open the fingers if need be, pneumatic especially. But yeah, I mean, it can, you can set that grid to have, the dimensions of the part, and then you can figure out, which we always help during an application, analysis, what the most optimal rows and columns would be for that size of part. I hope that answers the question.
Mm-hmm. Someone else wants to know if this also works with lathes.
Yes, of course. Sorry. We take this whole thing, and it also works on lathes as well. This was mill focused, but the same idea. We have that fine work holding or fine chuck, if you will, that we're rolling out for lathes. Dual spindle lathes has been very popular for us. So you can say in the job manager, if you want to load in the main, remove in the sub. We have the option to do a bar feed and then remove it from the sub, things like that. So yeah, absolutely.
What is the reach at full load on the 30 kilogram arm?
The reach at full load, there is a graph for it. I don't know off the top of my head. I'll have to get back with you on that. That's a universal robots.
Yeah, the reach, I'll just jump in. I have it in front of me here, but the reach on the UR30 is 1,300 millimeters. and in inches, that's about 51 inches.
Yeah, and I think the load on that, there's a graph as you get further away, that does taper. You don't have 30 kilograms at full reach, I believe, but I believe it's still in the 20s.
Okay. What is the average load unload time with a cobot with a single gripper?
We don't do a whole lot with the single gripper. That really just, if the payload is just so large and we're still trying to use like a UR10, for instance, we can do a single gripper. But the unload time or the load and unload time for that would be about 2 minutes. Thinking about, as we load a part, we go in to remove the part, drop it off, pick up another part, go back in. You're looking at about 1.5 to 2 minutes.
Okay. If you don't have a Hurco machine, does it cost extra to get it set up?
Once again, we go back to that partner. We only do on Hurcos with our job manager. It wouldn't, cost extra. I would say probably, not at all, but you're going to lose a lot of the features. So what we've done, have patent pending and things like that, that's solely exclusive to the Hurco.
Okay. What types of parts and processes are best suited for automation with ProCobots?
So I would say all range of parts, within reason. With the UR now offering 30 kilograms, we can do some pretty large parts. And then with the 20, we have our big machines, we can automate those as well. So yeah, it really just comes down to finding the right finger, maybe doing some custom fingers for a part, but all parts, I would say, are within reason. As long as, we need about 1/8 of an inch to grab onto it to accurately load inside the machine. That's the smallest. And then the largest is really limited by the 30 kilogram robot arm.
Okay. What is the max capacity of stock size you can use with the grid?
So like the largest size, am I hearing that right?
I think so.
Yeah. So once again, it comes down to any size. Like I said, you can make that grid a 1x1 and have it, the whole size of the grid. That's possible. It's dynamic. So you can, like I said, you can change the rows and columns, the grid size. It does not matter.
All right. What is the breakdown setup time when moving the machine or the robot between machines?
We actually have a video for that. I believe, Ethan, correct me if I'm wrong, we have a video on YouTube, right?
Yep. That video is on our ProCobots and Hurco YouTube pages. Yeah.
So we have a video that I was doing this back at a trade show in Wichita back in October. I was moving it from a mill to a lathe. If you want to check that out, I highly recommend that. It just shows it, almost in real time what we're doing. But it takes about from going to a mill to a lathe a little bit longer, about 5 to 10 minutes, because you do have to teach a couple points in the lathe. But going from a lathe to a mill, it's like as quick as you just saw that setup time, because you just roll it over to the next machine. Like I said, there's a quick connect, you unplug, and then you plug that in when you get to the next machine. Now with the mill, there's 2 air lines you have to add or plug into for the vise, but yeah, that's it. So it's really quick.
Okay. Is this system sold as is, ready for manufacturing, or does it require additional hardware?
Nope, we sell it all as the package. So the package is that is not, our package does not include work holding, but we work with you on what the right work holding is, because it depends by application. A lot of people, will have Kurt vises they want to automate, so we go with one, or we're doing something with an air vise or a shunk. So, but everything else, that's all included. We don't piece this stuff together. We sell it all as a package. We're there, or our distributor is there to train you so you know how to use the system. We're there for support, throughout it all and beyond. You have our contact, that kind of thing. So we're a full, top to bottom, all integration, and we are Hurco. I'm located here in Hurco. So you have the Hurco support through it all.
Okay.
Can I quickly jump in on just clarifying the robot reach, actually? So the 1300 millimeter, which is, like I said, about 51 inches, that is at full payload. Oh. You only actually lose payload when you're a few inches off the end of the arm, the TCP. So you don't lose any reach until that payload is about 4 to 6 inches away. So just to clarify that quickly.
I apologize. So yeah, so that we do not lose payload on full reach of the robot. It all just depends on when you're getting away from the tool flange. So as your tool gets further and further away from the flange, that's when that, you got, the physics not on your side. So yeah, that makes sense.
Thanks for that. Does this integrate with part probing to stop production on non-conforming parts?
It does. We've done that. We had a customer actually do that where they were doing probing every, they were doing probing every part, but if they had 3 bad parts in a row, I believe it was, which that was a variable they could change, the robot would then take that part and place it into it would take every bad part and put it into a bad parts container. And if there was 3 in a row, then it would stop operations and send a message. It would actually send an email out to the person to let them know that that the operation had ceased.
All right. What point does it make sense to replace a 1-shift operator with a ProCobot?
I wouldn't think of it as replacing an operator so much, unless the idea is just being an accessory or a tool to the workers that you have. But it really, if your machine is constantly getting fed work, if the machine's not down without work, then there's a place for a robot. The tedious loading and unloading of the machines and loading programs and things like that, and of course your part process, if you're cutting something really, hard and your tool life is variable and you don't have that down, then maybe there's some steps that have to be taken before automation but really, if you're doing consistent work, like I said, robots love consistency. So, that's when automation really makes sense.
What is the most efficient way to flip a part for first and second setup with a ProCobot?
Like I showed you, I'll kind of go back here to this slide. The most efficient way to do it for us is a part flipper inside of the machine. Back up. So just play this video. So yeah, this is really the most efficient way. It's inside of the machine. It can quickly just load it in here. Make sure it's nice and clean, do the flip. As you can see, this doesn't take but like 30 seconds to do the whole operation. That's the best way to do it. So that allows us to do multi-op processing. We even have it to where we have a customer that's doing 2 operations here, pushing it all back into the grid corner. And then after it's ran that job, the next job in the queue then takes that and runs a 3rd operation. That's why there's 3 vices in here actually. So yeah, that's the most efficient way to do it.
How accurate does the unit placement need to be in front of the machine?
So it doesn't. We try to eyeball it nice and straight so the axes of the robot line up to the machine axes to somewhat. But because it's so easy to set the position inside the machine, we don't have to really worry about being consistent. We've had people put some tape on the floor so they get it in the ballpark. But yeah, I'm just showing, where to place the part and remove it is all you have to do.
All right, we have a couple of people asking if this system can be used with older Hurco models or only on newer generations of machines.
Yeah, so this setup here with the job manager is just on the I machines. So I believe 2014-ish or so, when we went to like the darker gray skinned model with the I at the end of the machine name, that can be compatible with the job manager. Now, there was about a year or so period where, we were still using the Max 4 controls on those I machines. So those can run the job manager, but we have to have a special tablet that we add on there to run the job manager because the older Max 4 doesn't have the operating system compatible with the job manager. But we can do it all just the same. It works all the same. And then before that, the older machines, as long as it's an ISA rack, if that means anything. So I don't know the year generation, but I would say probably like 2009 and on or so, roughly. Don't hold me to that, but we can do more of a traditional integration, but still, offers an automation solution that you can do. You can't queue multiple jobs in a row with the job manager, but we can still automate a part, and we do more on the robot teach minute to enter that data.
Okay. Do you have experience loading billet for Op1 into a 5-axis rotary and then moving the part into a vise for Op2 to finish?
Yeah, so like with our SRT machines, you can have the 5-axis on the C table there. Of course, we can take that part out, just like with the part flipper, if there is no flip required. So if you can rotate, which in the SRT, that's not really the case. But yeah, we can take the part out and place it into a different work holding. Whether the type of machine, it doesn't matter. It would just be like this without the part flip, essentially.
Okay, I am bar feeding a twin spindle with a huge variety of work at low volume. I need an arm to manipulate my collets in the right spindle and unload parts. I also need a solution that can be moved away and reoriented globally, not by each program. Is this a viable solution?
That's a bit loaded. Yeah, so I think first part, loading. So yes, bar feed, remove from the sub spindle. It mentioned to collet. We can remove parts from the sub, no problem. That's just a simple toggle where you're going to remove it. And then what was that second part, moving the machine around?
I need a solution that can be moved away and reoriented globally, not by each program.
Okay. I think I understand, like moving it from like based on the need, possibly.
Doug, if you want to send in another question and clarify, but Stephen, if you want to do the best with the information we have right now until then.
I mean, we can move it around from machine to machine, like I said, anywhere in the shop based on the needs. We actually had a customer doing that. They had our MYS machine and a 5-axis, and they were moving it back and forth between those two based on the workload. Also ask about the collet. If they actually want to remove the physical collet, that would take custom fingers, but also doable.
Okay, he says if I move the robot away, when I bring it back, I need to relocate it once, which is then effective for all programs.
I see. That is not correct. It does have to be done for each program.
Mm-hmm.
Yeah. So yeah, there is not a global position for loading that each job, because the job file itself contains the specific load and unload process. But I like where you're going with that, especially on the lathe where the Z center line doesn't change. That's something we may. I'm going to take note of that. Thank you.
All right. We have a couple of people asking if this robot can interface with multiple machines at one time, like in a cell.
No, we focus on one robot to one machine. I mean, we have done special case where we had one robot between two 10Us that was loading on the side doors to each side, but that was kind of custom special case. I wouldn't say that's something that we, really do consistently or offer as like a solution. The main thing is, typically with the reach of the robot, you can't really get two machines close together like that. And we don't do anything with like a 7th axis rail back and forth or anything like that.
Okay. What kind of maintenance is required for a ProCobot, and how frequently should it be performed?
Yeah, so really the robot doesn't have any maintenance. There's nothing you have to oil or grease. These robots don't have batteries that you have to replace like some robots. So largely just maintenance free, just keeping them clean. They are sometimes in pretty harsh environments inside machines. I mean, we've all been in machine shops. Sometimes coolant can be left untreated and get kind of messy or dirty. So it's nice to keep the robot clean, just to prevent any kind of gumminess and things like that. That'll help increase the longevity of the robot. But yeah, that's pretty much it. UR does have a list of maintenance things just to make sure that, things are nice and tight. But as far as consumables or anything like that, there isn't anything.
All right. How does the ProCobot handle complex part geometries or variations in part design?
Yeah, so having that adaptive gripper with the Robotique especially, it can range, open a range to grab multiple parts, different size parts. Having the dual gripper set up means that you can have two different styles of fingers. So we've done it to where, traditionally we have gripper 1 do all of the loading and gripper 2 do all of the removing. But we have had lathe situations to where we used gripper 1 to basically do an ID grip to load and unload, but gripper 2 would do the flip. So different style fingers to do that. Really just customizing the fingers and the work holding to accommodate a range of parts and grids as well. And, like I said, we offer a whole package. So when we look at a customer's application, we go through what the right fingers are, whether we manufacture them or you're a job shop, maybe you can make them. And we don't obviously charge for that. We just tell you what we're thinking and have you make them. So just comes back to owning, the system. So, yep.
All right. We have a couple of people asking about cost. Do you mind ballparking a number for the audience?
I'll give that to Ethan.
Okay.
Yeah. So we have a really competitive price in the market, especially for how robust our system is, and it's a full turnkey package. So I can say generally, most systems for most customers, it is different. Some customers want multiple work holdings, they want to add a part flipper, all sorts of options, but most systems are well under 6 figures. And we do have promotions and deals going on, especially going into IMTS. So if you'd like a more exact quote, feel free to reach out to us. We can get you one or set you up with Hurco distributor or one of our partners.
Awesome. I have one more question here. What improvements in cycle times and productivity can be expected with ProCobots?
So it's really just about being consistent. Consistency is key. So, of course, when you get a human next to a collaborative robot, as far as speed goes, the human's going to win every time. But it's all about that consistency. If you're, 3 seconds faster than the robot, but you go and take a 20-minute bathroom break, you lose all of that. So the robot is, efficient and it's consistent with what it does. And that's where it wins. And it can do it lights out throughout, breaks, holidays, weekends, overnight, things like that. So, yeah, like I said, consistency is king.
All right. That's all we have time for today. I want to thank Steven, Hurco, and ProCobots for making this webinar possible. And thank you to everyone for listening in. You should receive an email with a link to the recording of this webinar soon. So thank you, everyone, for your time, and enjoy the rest of your day.
Thank you.